7 to 8.
Testing. Okay, in this session, I'm going to review some questions that can help students to complete assignments that are related to the bouncing ball. Okay, the name of the assignment is called recursions underscore exponential function. Okay, on top of the title, you should see using recursion in models and decision making, recursion in exponential growth and decay. And in detail, it has activity about bouncing ball. All right, let's go straight. So for this assignment, in the soft chalk, when you download the assignment, it's in the PDF format, okay? But in here, you can download a Word format, or for any PDF document that you want to convert to Word document, you can also search convert to Word, PDF to Word online, and then you should find something for free to convert it. But here I have converted it to you. If you click at the Spring 2017 file, underneath there is a m4.recursion exponential file, and that is a Word document .docx that you can type your answer in. All right, let's go straight to explaining our homework. So this is not exact questions like your homework. However, they are similar. Remember, your homework, this is your homework. Let's see. The first two questions of the homework is basically already completed for you, but from the interaction above here. In this interaction, when you click through it to understand the lesson, it's already completed for you. You just print out the handout or transfer the same answer into your paper when you submit it. You don't actually have to create your own data for the first two questions of the homework. Okay, so go back. All right, so the chat below, let's see. The chat below gives the recorded height for each bounce of the ball. If the original height of the ball is 50 inches, estimate the rebound percentage for each bounce of the ball. Okay, if you study the content, a rebound percentage, you use the number from the next bounce divided by the original height. So in this case, your rebound percentage will be 24 divided by 50, then multiply by 100. Okay, so take a moment to calculate it. And that should be similar to 11.52 divided by 24 times 100. Okay, and that number should be similar to 5.52. They don't always be exact, but it should be pretty close. Your rebound percentage should be pretty close. The number that you get for these three, you will add them up and take an average of it. So let's calculate our rebound percentage. So this is 48%. And you calculate the second one. You should also get 48%. Remember, this number is not always the same. In this sample, it's the same because for whatever reason, this ball probably is perfect. This is 47.9. So I would say close to 48%. All right. So the rebound percentage is equal to 48%. Okay. So that's the rebound percentage. Good. If you have any questions, when you're watching this, please send me an email. All right, now we're going to move on to the second type of questions. Tennis balls are sealed in a pressurized containers to maintain the rebound percentage of the balls. A tennis ball has a rebound percentage of 55%. When it is taken out of the pressurized can, suppose a new tennis ball is dropped from a height of 3 meters into a tennis court. So, what do we want to find? Write the function rules. The function rules mean the explicit formula. The formula that doesn't require the previous term to calculate. Okay? The formula that you can calculate any term as long as you plug in the number of terms. That's the function rules. Okay? So this is a generic format of the function rules. So what is A sub 0? A sub 0. Wait. A sub 0 is the initial height, okay, the original height. So the drop height from here, the drop okay. And then what is R? R is the rate. In this case, is the rebound percentage. Okay, in this case, is a rebound percentage. But it has to be in decimal. All right, and n represent the number of term. Okay, so we have this number, so we know what is the original drop height, right? The original drop height in this case, we got it here is 3. It dropped it from 3. So what if they change the drop height? Then you would change your formula by changing that number 3. But this case, they drop at 3 meters, so you just your A sub 0 is 3, and make sure you put parentheses. And the rebound percentage is in percent, but you need to change it to decimal. So 55% here is equal to 0.55. Okay, so you do 0.55, and then don't forget the exponent end. When you are typing, if you're typing your work in the Word document and you do not know how to use exponent sign, you can do this. You can do a underscore n equal to 3 parentheses 0.55, then little hat, and that tells me that it's the exponent, the little hat. That usually is shift 6. Okay, great. Now move to the next question. What is the height of the fourth bounce of the new tennis ball? So fourth bounce, meaning your n is 4. All they want you to know to see whether you know how to use your function rules that you just created. Your function rule is above, so you just plug in the n as 4. This tells you the height of the fourth bounce. This is the height of the fourth bounce. Use your calculator. Make sure you know how to use exponent. Remember PEMDAS, you always have to do the exponent first before you do the multiplication. So 0.55 raised to the fourth power. So this is 0.2745 meter because the original measurement is in meter, so your answer also in meter. Okay? If you have any question, remember, email me. Next, look at the next type of questions. Tennis balls is the same situation, except now they want to ask, number 3, how many times does it bounce before it has a bounce height of less than 20 centimeters? Okay, so you know a 3 meter, each meter is equal to 100 centimeters, right? So when there's 3 meter, if you look over here, 3 meter meaning there is 300 centimeters. So I want to know, I convert it to centimeters so that when I do calculation, I just do below 20. I want to know at what part, at which end here, when I calculate this answer is less than 20. Okay? And from the previous questions, I know at fourth bounce, it gives me 27.45 centimeter, a meter, right? That is actually equal to 27.45 centimeter. Okay, so that's actually equal to that. So therefore, I know, okay, it's either fifth bounce or sixth bounce, right? That's not much. So how many times does it bounce before it bounce heights of less than 20 centimeter? So at fourth bounce, I know it's 27.45 centimeter. I'm just going to test the fifth bounce. So what I'm going to do, I'm just going to plug in to see what is the bounce height at fifth bounce. Okay. I just want to calculate this. And all I got to do is from my, if I haven't cleared my calculator, to multiply another 0.55. And then I calculate it's 15.0 98 or 15 point. Let me see. 15.1 centimeter. Okay, so I know at fourth bounce, how many times does it bounce before it has bounce height of less than 20 centimeter? So it's 4 times. How many times? 4 times. The fourth bounce is the last bounce that is beyond 20, and the fifth bounce is already below 20 centimeters. Okay, so it's the fourth time. 4 times. Now the last questions. What is the total vertical distance that the ball travel after 4 bounces? Alright, so here's my formula. Let's transfer it over. AN equal to, let's write in centimeter. 0.55 to the power of n. Alright, so this, listen to this. This is a little tricky, okay? So your ball starts at 3 meters. That's 3 meters. This is the ground. Right, this is the ground. And that's 3 meter right here. 3 meter mark. Okay. So when you drop the ball here, right, the ball fall, and then it bounces up, right? It doesn't bounce as high as this, but it does bounce up. And then it come back down again. And then come back up. Slightly lower. Go back down. Come back up. So this is bounce 1 time, 2 times, 3 times. Come back up. Down. 4 times. Up. Okay. So this is 1 time, 2 times, 3 times, 4 times. So this is a fourth bounce. So what we need to know is all this dotted line, okay, consider is a distance is traveled vertically. So how far does it travel total? So I know that this is 3 meters. So when it comes down, it has to be 3 meters, right? And then when it's bounced back up, that's my first bounce. So you can calculate based on your calculator, your formula, what is the height of the first bounce? Then you know what it is. Okay, so 300 times 0.55. So it's 165 centimeter. Okay, so this is 165 centimeter. And when it come back down, it's also 165, right? Right? Because that's how tall it went, and then this how far it has to come back down. And then we're going to calculate the second bounce. I'm writing out the whole calculation, but all you've got to do on a calculator is times 0.55. It's 90.75. So on the second time, he only bounced up to 90.75 centimeter. So this two, for this two is 90.75, okay? It's not enough room to write all of them. For this one, for this side, and this side, okay? Bounce 2. And then you calculate bounce 3 the same way. You just multiply by another 0.55. You got 49.91. And bounce 4. You got 27.45. So here, so you, if, what? Okay, wait. So the ball fall from 3 meters, bounce up 1 time, first bounce, second bounce, falls down from here, first bounce, second bounce, third bounce, fourth bounce. Okay? So we want to know the total distance all is traveled. And all you got to do now is to add the number that we have calculated. The third bound is 49.91 and the fourth bound is 27.45. All right, so the total vertical distance is equal to 3 meters plus 2 times 165, right? Because they are up and down. Plus 2 times 90.75. Is up and down. Plus 2 times 49.91. 2 times 27.45. So once you calculate that, is 669.22 centimeter. Okay, so you can give me answer in centimeter or meter. This is how you're supposed to do it. And the analyst is in a picture. All right, again, if you have any questions, email me. And again, your assignment, the first 2 questions was already given. And make sure you use the Word documents, just type your answer in between. If for any other future assignment I didn't provide Word document, you can always convert it using the PDF converter. Search online. There's a link under user links in the course. So, and here it has the assignments looks. If you have any questions on these, all these questions are already gone over in a sample question before when I go